Dear students, today we are going to discuss about a very important reaction, Reimer and Tiemann reaction. So, which is a very important reaction from alcohols and phenols. So, in this reaction, what happened in this reaction? In this reaction, the phenol is converted into the phenol is subjected to orthoformylation, or the phenol is converted to salicylaldehyde chemical. The salicylaldehyde chemical further oxidation will give salicylic acid. Salicylic acid, which is the raw material for the preparation of aspirin, which is analgesic medicine. Hence, the Reimer Tiemann reaction is very, very important for us to learn. So, in this reaction, the phenol is converted into salicylaldehyde in the presence of chloroform and strong basic solution. You take potassium hydroxide or sodium hydroxide, you can take. The reaction conditions we provide is that at 340 Kelvin temperature, the strong basic solution and the chloroform we should take. But the chloroform doesn't dissolve in the aqueous solution of sodium hydroxide. Then how the reaction takes place, how the reaction mixture, how the chloroform and sodium hydroxide combine. So for this, we need to take PTC, phase transfer catalyst. Phase transfer catalyst we should take, and in that solvent we should mix the chloroform and basic solution, strong base solution, and we must heat at 340 Kelvin temperature along with the phenol. Then the phenol undergoes orthoformylation process. Then we get 2-hydroxy benzaldehyde, which is called salicylaldehyde we can get. If you want to understand the complete reaction, how this 2-hydroxy benzaldehyde is formed, then we should discuss the mechanism. So what is the mechanism? So now let us see the mechanism of the reaction involved in this. Now, so what mechanism is involved in this Reimer and Tiemann reaction is that in step 1, the chloroform loses a proton, which is called deprotonation by alkali solution, deprotonation by strong base. When the chloroform react with this aqueous solution of, potassium hydroxide, the strong base will abstract the proton from this chloroform. The proton is taken, which is said to be deprotonation. The sigma bond electron convert into lone pair here. Then the carbanion of chloroform we get, the carbanion of the chloroform, the carbon holding the negative charge here. And when the carbanion of chloroform, the negative charge causes elimination of chlorine means chloride ion, resulting the carbene ion of chloroform we get. The carbene ion of chloroform we get. So the carbon holding two chlorines and a negative charge, and it will carry the positive charge. The carbon will carry the positive charge since the chloride ion is eliminated. When the phenol is mixed with the aqueous solution of the potassium hydroxide, the potassium hydroxide the potassium hydroxide will eliminate this, so or make the phenol to sodium phenoxide or potassium phenoxide. What you say here, selection of the based on the base. The potassium hydroxide will make the phenol strong nucleophile character, and potassium phenoxide is formed. If you take sodium hydroxide, sodium phenoxide is formed. This potassium phenoxide highly reactive because of strong nucleophilic nature. So, and this oxygen group present on the benzene will make the benzene ring more nucleophilic center. Hence, this is more reactive than attracting this carbene ion. So when the carbene ion carrying the positive charge attracted to the pi electrons, then the pi electrons are used for making bond. Then, so when the carbene ion is electrophile is combining with this second position on the sodium phenoxide, there is deprotonation by the phenol takes place, and by the deprotonation, the proton shifted to the carbene's negative charge of the carbene. So then sigma bond of this hydrogen is converted into pi bond electrons. Then oxygen again getting the negative charge here. So the next step, again, it is hydrolyzed by the potassium hydroxide solution. So one of the chloride ion is removed by the OH minus ion. OH minus ion. When the OH minus ion is substituting the chloride ion here, the hydrogen proton shift to this phenoxide group where the sigma bond electrons so move towards between the oxygen and the carbon. And during this process, resonance of this electron sigma bond moving towards between oxygen and the carbon, then one more chloride will be removed, and then it conforms so formyl group at ortho position. So the phenol got the aldehyde functional group at the second carbon is formed due to the elimination of one more chloride. All the chloride ions combined with the potassium ions will form potassium chloride. And so this is the mechanism involved in the Reimer and Tiemann reaction. The first step is the deprotonation and the formation of the carbanion ion of the chloroform. For it loses again, so chloride ion because of internal strain, repulsion between the negative charge and the halide. So, and the formation of the carbene radical. This carbene radical attack the pi electrons of the benzene ring of the phenoxide ion, since the phenoxide ion is more reactive. So this is the mechanism involved in the Reimer and Tiemann reaction mechanism. So the final product is that 2-hydroxy benzaldehyde is the final product. So this is the material used for the preparation of aspirin analgesic medicine. So thank you so much.